Another type of inequality problem you'll run into on the exam is the word problem. Get to know all the prompts for inequalities. At least means greater than or equal to. At most, less than or equal to. No more than, less than or equal to. No less than, greater than or equal to. The age of the tree is at least 70 years, means age is greater than or equal to 70. For each of the word problems, you want to read the problem carefully, define your variables as we do in most every word problem, set up the inequality expression correctly, solve that inequality, and then answer the question. Let's see an example. Suppose I had the following inequality, word problem. The sum of two consecutive integers is less than 55. So less than 55 means less than 55. And I want the sum of two consecutive integers. Well, I don't know what the first integer is, but if I define it as x, call that my first integer, I do know the next or consecutive integer is going to be x plus 1. Consecutive numbers are 2, then 3, 4, then 5, 20 and 21, etc. Okay, so the sum of these would be x plus 1, or 2x plus 1 is less than 55. This is the relationship, the inequality that denotes the word problem situation. Now I can go ahead and solve. So I'll subtract 1 from both sides. 2x is less than 54. Divide through by the coefficient. X is less than 27. That's not my answer. Be careful. We always have to read the question. Find the pair of integers with the greatest sum. So what is that pair of integers? Well, it has to be less than 27. So it'd be 25 and 26. That would be the pair that has the greatest sum less than 55. Sum happens to be 51, but the pair is 25 and 26. Let's look at another example. Suppose Charlie has $500 in a savings account at the beginning of the summer, but he withdraws $25 each week to spend on food, etc., and he wants to have at least $200. What does at least mean? Well, that is greater than or equal to 200. At the end of the summer. So, okay, so how do we think about this? He has 500 in his account at time 0. And then 1 week passes, he subtracts 25, he has 475. And then the second week passes, so that's 2 times 25 he spends. So it's 500 minus 2 times 25. So the general expression is 500 minus 25 times, let's call W, the number of weeks that pass. So every week he spends $25. So we subtract 25 times W, the number of weeks, until he gets down to, but not less than, $200. So this is the inequality that expresses the situation in the word problem. And I can begin to solve. I'll add 25W to both sides. 25W is less than or equal to, if I subtract 200 from both sides, it's less than or equal to 300. Divide through by 25, the coefficient of W on both sides. I isolate W is less than or equal to 12. Charlie can go 12 weeks before hitting his lower limit. Let's take another example with fixed and variable costs. So the yellow taxi cab company charges a $2.75 flat rate. So they charge $2.75 once you get into the taxi, regardless of how far you go, and 65 cents for each additional mile. Emma has no more than $14 to spend on the ride. So no more than $14. That's basically less than or equal to 14. How many miles can Emma ride without exceeding her spending limit? So the variable we'll define here, the unknown is number of miles. We'll define that as M, and we want to know how many miles M can she travel on $14. So she's got her fixed fee of $2.75 plus her variable cost of 65 cents, 0.65, times the number of miles M. And that can be no more than her total amount of dollars available to spend, which is $14. So that's our inequality set up. Now I can begin to solve it. 0.65 M is less than or equal to 14 minus 2.75, subtracting 2.75 from both sides, which gives me 11.25. And I'll divide through by the coefficient 0.65 on both sides. And M is less than or equal to Well, this won't be an exact integer amount. It should be something like, looks like 17.3, which is going to round down to 17. So a lot of times inequality problems require you to either truncate, get rid of that remainder or fractional amount, or possibly round up. So in this case, we're getting rid of it because you can only buy a whole number of miles. She can go a full 17 and not spend $14. But if she goes 18, she'll spend more than her budget. So she cannot buy that last mile. 17 is the correct answer. That's the maximum number of miles she can ride. So on inequality problems, pay attention to the logic of the problem. Do you have to truncate, get rid of that remainder or fraction, or round it up? Depends on the exact wording of the problem.